And about 8 months ago, I started with Mapr, but I've been dealing with data since the early '90s when we were trying to figure out how to get mobile data to the battlefield in the Army. We were shoving in Cisco routers in a rucksack and jumping on the back of an airplane and parachuting to the ground and see if we can't get some classified and unclassified data feeds up through single channel TACSAT. So that was my first foray into the realm of data, and it's been an interesting journey throughout that whole process here. But today I want to talk a little bit, I'm not here to kind of pitch one way or the other. This is more of an educational conversation. There's a lot of discussion about the different distributions. And I just thought I'd take a little bit about some of the differences that Mapr came into play, where we came from, and why we've had such a successful foray into production environments. I don't want to sit there and yak too long. I'd like to get some hands-on or some actual looking at some live systems near the end of this conversation. But I want to go through. I mean, it's an open forum here. Please feel free to jump in and ask some questions as we go through this. But this is just a. Well, that's nice. Well, it's clicking here. It's not clicking there.
Oh, okay. Is it plugged up? Maybe it's free.
That's just Apple reminding me who's in charge. Oh, there we go. So, this is we've got several offices throughout the world. Seen many of these slides. Blah blah blah. Some bit about where we came from in general. So several years ago, I guess it was the 08 time frame, our founder, the smart guy here, this is the guy, the money man, right, the CEO, the smart guy, MC Shrivas. He worked on and helped build the Andrew file system. He's well-versed in file systems in general. At the time, if you look at the evolution, I know you heard a little bit earlier about where Hadoop came from and kind of what it evolved through. But at the time that after Hadoop was starting to really take off, Shrivas was working on at Google building out Bigtable, and he took a moment to look at where Hadoop came from, where it was going, and decided there needed to be a couple of things. Thanks. There needed to be a couple of things that would make it much more effective when you get to a real production role environment. And that kind of led to the beginning of Mapr. So when Mapr was first founded, we took some time to go back and look at the actual file system that Hadoop uses, the HDFS file system, and we made some architectural changes there to maximize its capability to do things. And I don't want to go into, we'll go into some of those details here, but since we've done that, we have been recognized as one of the top-ranked distributions when it really comes down to look at getting started with your first Hadoop case. The most important thing is getting started with your first Hadoop case, but not exactly which it should be run on. When it comes to cloud leaders, right? If you look at, you can both Amazon and Google in their cloud offerings for Amazon EC2 or Google Compute, they offer vanilla standard Hadoop Apache Hadoop distributions, and they offer a Mapr distribution. That's what you get when you scale to the cloud with those guys if you're using their distributions of Hadoop. We've got more than 500 plus production customers. And those are customers that are using this in their core business, right? So it's part of how they make money every day. And like Fred said, we're going to talk a little bit about some of the more extensive use cases, just from a standpoint of just using it in a production environment. But I think one of the largest ones I've been able to work on with the customers, 1,400 nodes with 47 different applications, feeding 17 different business units, administered by 2 people. All in one cluster. So from a standpoint of, we've been recognized for our distribution this year. We're also recognized for our NoSQL offering as well. So because of some of the architectural changes we made, we were able to really decrease the average latency. So we have a uniform latency for any NoSQL operations. And really the way it works, I mean, it's the fastest NoSQL operation you can get on Hadoop. And when Forrester pulled down and took a look at the NoSQL offerings that existed, which is the NoSQL, this one over here. So when Forrester pulled down and started taking a look at all the NoSQL offerings that existed out there, there was only one flavor that made it onto their list of even qualifying as production grade or as leading that it was in Hadoop at all, and that was the Mapr distribution or Mapr database. Sorry, two or three more slides here, and we'll ditch this. But
So these distributions that you have, is there a custom component of Mapr that you can use, for example, NoSQL or the other part?
so, I mean, for example, if you look at the file system, we're going to go through the details of the file system and some of its differentiations and what that actually means. But when you're looking at what that means from a actual deployed standpoint, if I have a distribution over here in Cloudera and a distribution in Hortonworks and a distribution in Mapr, what's that mean from my data perspective? Access-wise, nothing except you get additional capabilities, right? Moving data around. If you're going to move data from one distribution to the other, you're going to do it the same way, regardless of which distribution it is. So, I mean, the only aspect of it is, what I like to say is from a data perspective, from how you move that data, how you own that data, it's extremely easy to move the data into Mapr. It's also just as extremely easy to move it off of Mapr and move it into something else. So the only way I keep things going on is I provide appropriate value to someone to do. We do, and I'll cover the free edition as well, because just like any other of the distributions, we offer a free edition, it's a community edition. It has all the unlimited node count for all the features that I was talking about, the file system, the database, all those kinds of things you get for free. What comes into the specific aspect of a license or anything else is going to be enterprise-grade type of feature sets. Right? But we'll cover some of those. For performance-wise, this is a little bit dated. I like this one because this is one. It's pretty local. It's a Texas team. So these guys down here in Austin put together this distribution or this test. It's the Flux 7 Labs out of Austin. This is a 2013, so it's pretty dated now. I have been able to find a new third-party comparison. Mapr had nothing to do with this. Hortonworks, Cloudera. You can tell it's a little bit dated because it's still got Intel up there, right? But these guys came across and published this. They were testing the lab down there. This was their results. All the details are published behind it, but I don't want you to get hung up on the numbers. That's not the aspect of it. When I look at architectural speaking or differences between different distributions, regardless of what those distributions are, this month and next month is not what you look at. You look at for the last 6 months, what's been going on, and get the kind of trend is what's happening in the community and how it's supported and how it plays. That's what tells a better story than the latest blurb from, whether it was a latest marketing blurb that came from Mapr or anywhere else, right? You want to look at it a little bit longer. This is another example. I don't like world record number performance things. This is an example of a Mapr customer who broke the world record aspect of it. But I don't like these. I mean, they change from month to month as people do different things in the different distributions or run it a different way or have different node counts, different aspects of it. What I want to point out only on this slide here is architecture matters. And it's different from 2,000 nodes and 300 nodes. That's a fairly common trend for when we roll things out there, is a 30 to 40% reduction in hardware. So, not always the case, but 99% of the time. Now, that type of technology, that type of architecture, what it allows us to do is one of the things that we're trying to get to with Hadoop in general is removing of data silos, right? In the traditional space, we've got all these different types of data sets everywhere, and people are having to look at it over here, then move data over here to look at it in this test or this location or in this group, and it moves back and forth as they try to look at all the different types of data they have out there. One thing we're trying to do is get all the data into one cluster. So that's one of the things that we like to do with the Mapr distribution is pull as many different silos, one cluster, not 100 nodes of 3 clusters, but 100 nodes of one cluster where all the data from all the projects all resides and runs in the same cluster. So in this one, here's an example of a large credit card company, and so they've got the batch aspect. This is a Lambda architecture. You've got 2 use cases of the 17 that they run. You get 2 use cases here. The batch analytics is going to run on all the different transactions of their different customer bases. We're going to look for normal patterns with machine learning. Right? We want to look at what's a nominal, what's a regular pattern. Then as real-time transactions occur, we want to apply that to what we know as a normal good pattern to look for the anomaly aspects of it, so we can then generate alert methodologies and alert procedures so that we can then make decisions about that to determine if is this one anomaly, is it 2, do we need to turn off the credit card until somebody answers the text message that says, hey, is this you? So now one of the aspects that you find with this data set, and this is a common thing, it's just one of the things that Hadoop is being fairly interesting and disrupting and kind of growing in the market, is you got smart guys that spend a lot of time doing these algorithms that are so capable and accurate, but a lot of times what beats a better algorithm is more data. So the more data you can pull together, the longer view you can have, the more accurate, the more you can adjust, the more you can make decisions that are more relevant to what you're trying to do. So in most cases, more data beats a better algorithm. And that's one of the things that we can do with any of the Hadoop distributions, but it extend the ability to hold that data longer at a cheaper cost. Now that was one particular use case. Now after that one came up, immediately we had a second use case that came into play. So there was an existing service. You got the mobile app, and of course we all walk around with a mobile sensor platform in our pocket. So with the mobile app installed, these guys could know where all their customers were going and what they were doing and when they got off the plane and what their location was. So they tried to start sending them coupons and references to get them to buy and do different things as you try to make money by offering that service to different companies to then feed to their customer base. But they weren't getting the proper uptake. So once again, we start a lot of batch learning, combining what we know of the purchase patterns associated with an individual, with how they use and spend money, to what have they accepted in the past, if anything, as well as where they're at, all the information about where they're coming from, what their location is, so that when they get off the plane, when they land in California and going to go out to some conference in San Jose, they can say, hey Bob, I know you like Italian food, and you spend about $20 to $25 when you go eat. Well, here's a deal for you. Here's 30% off the restaurant that's 2 blocks from your hotel you're staying at that you just checked in for 20% off an Italian meal. It's in your price range. So that's the kind of things that they started to be able to do, because once again you start to have all of that data in one location where you had siloed activities before in 2 different clusters. Bring that together in one operation in one cluster, and you can start to have real-time operations around multiple projects, leveraging things that are going on across the board. And that's the benefit of trying to pull as much as you can to one cluster at one time. Make sense? Somewhat? This is another example, right? I mean, the whole point here is that the largest customer I have that I said I've been able to work on, as I said, 1,400 nodes, 47 applications, right? All in one cluster with 2 administrators. That's a pretty difficult task, but they're able to manage it. And we'll talk about some of the reasons why. But you've had a little bit about General Hadoop and kind of where it came from. It's come a long way from what it was 2 years ago. It's gotten a lot more advanced than in the last 2 years. But there are some differences between what Mapr did and kind of what exists, what our founders decided needed to happen. Now, the first aspect of it is this is a quick review. I know you guys just covered some aspect of this. You talked about the name node, different aspects of it, right? How many files it can have, right? In this configuration, you got 50 to 200 million files. And originally, right, there was some issues with bottlenecks associated with the name node process in general. You've got all the data distributed here and all the metadata associated in one location. You started to expand aspect, right, to get rid of to kind of reduce the issues with high availability and 0 point of failure by adding in a second name node so that you can have capability of doing that, failover and those kinds of things. A giant leap forward. Still had all the metadata up here, all the data down here. Still were limited to how many files we could pull in. Then we move out, right? Now we start doing federated namespaces. And federated namespaces, right, we're dividing the names across multiple name nodes so that we can then say this name node handles this much of the namespace, this name node handles this much of the namespace. So now we can really expand what some of those numbers are. Now we got a billion files. We still all of it still has to go back to the name node, and each of the namespaces in themselves only handles a slice of it. So you have multiple aspects. You got to make sure you're highly available across each one of those stacks of H8 federated namespace name nodes. But the difference between that aspect and Mapr is Mapr decided that when we went back and did this, we got rid of the name node feature. So we made decisions about the file system to begin with, how we were going to store data, how it was going to reside in the system, and we got rid of the name node. So there is no name node. The metadata is propagated and distributed across the file system. So there's never a chance of you losing your metadata. Your metadata doesn't get lost. From the standpoint of the last time we did a disruptive test, it was you had everyone had their configurations, their systems up. You start yanking cables and pulling out power cords and just tearing the whole thing up and flipping breakers till it goes off. Turn it all back on, and it actually takes longer for the systems to boot than it does for the system to become active, reading and processing data. So the recovery time point for a complete shutdown crash or a complete power loss, where you yank everything out, turn it back up, is minutes. And that's a lot of that's around some of the aspects of it, just in the name of it. Of course, you want to make sure you don't want to have just a sudden power failure, but it's one of the things we do. So there's no special configuration for HA or for disaster recovery or for snapshotting. For the metadata is persistent, regardless of the power conditions or what happens. So there are aspects of it, you can load it in memory for speed, but for the most, but the data always resides in disk, and it's distributed throughout the cluster, just like your actual data. The metadata is distributed just like your data for protection against loss.
So you used the word distributed. You didn't say copy. You didn't say it's the same on every single node.
No, it's not the same on every single node.
It's distributed.
So it's distributed, and it's also replicated as well, just like the data. So you have 3 copies of that aspect of it. Depending on how many files you have, maybe there'll be 5 to distribute some of the work aspects of it. Going into all the exact details of everything that happens there, I don't think anyone wants to sit through that level of discussion today. But for the most part, what we try, the data is replicated and distributed throughout the system, just like your actual data, right? So the metadata is protected that way. One of the aspects of that is the trillions of files. So we can have 1 trillion files as opposed to 1 billion files. Lots and lots of files. Files are not an issue, and also the size, not the count of the files, but also the file size. So it's much easier for me to handle 64 kilobit files, all the way up to 2, 3 gig, whatever the file aspects of it is. So it's just a different way of looking at kind of what we did from a Hadoop standpoint. That is the biggest thing that people have questions about Mapr on is where it came from and what goes as expected. From a standpoint of your Hadoop replication, protecting your data, right? It's all the same. From a standpoint right there, right? You're going to copy, Hadoop makes multiple copies of it to make sure it doesn't fail over. We do the same thing in that regard. The snapshots are slightly different in that our snapshot is actually the file system data, first and foremost, not the metadata, with the file data to follow later on. And that's because of the fact that we don't have the name node. The metadata is distributed in part of the file system. When you take a snapshot, it's recognizable at an 8K level. So as 8 kilobits come across the wire, that 8 kilobit level of that snapshot, that's where that snapshot occurs. A lot of people, if you're doing analytics, if you're doing fraud things, if you have regulatory constraints, that is an important aspect of it. Of being able, when you do a rollback, when you take a look at a snapshot, it is a point-in-time snapshot of what's going on there. As an example, because of some of the aspects of just the architecture of Apache Hadoop in general, when you write something into it, it doesn't exist until you finish writing, right? You close the write operation, that's when it's there. So if I'm writing a large file, I take a snapshot, I look at it right now, that file doesn't show up. But a couple of minutes later, 20 minutes later, whenever that write process is done, I go back and look at the snapshot again, the file is there. So some people, that's important, some it's not. Yep.
So I'm hearing Apache a lot. I'm just curious how many people in the room have ever spent any time on a platform like that.
A platform like
Apache.
Apache Hadoop?
Just Apache in general, I guess.
Apache is just a project. It's a collection of projects.
Okay.
When I talk about this, a lot of the aspects of it, all the distributions use HDFS except for Mapr. That's one of the core aspects of our difference. So when I say Apache Hadoop, I'm really referring to all of the distributions for the most part.
So you mentioned about compression. What kind of compression rate would you get? Would it be the same across 1:10 or 1:8?
Well, it depends on which particular compression methods you want. So LZ is one, right? You can use a gzip aspect. So depending on the type of compression you pick will change the compression aspect of it. So there's multiple compressions you can choose to pick from. You can base that on the transport. You can base that on your file location, your folder, your directory structure as well. The point around a lot of the point of everything that exists here is to give options. So there's multiple file compressions so that you can trade off certain projects. You can trade off speed for greater density, greater compression, while some other ones I want to turn compression off completely because of the nature of the SLAs or the product that I'm running. Everything about this is designed to give options for a production environment so that when you get to be successful with Hadoop, you're not punished and you can adapt it to function in use cases and keep all your projects in one cluster to be able to really maximize that data and time you spend collecting it.
Can I just give some feedback there too? So,
This is Mike Zawala,
Yeah,
he's my
sorry.
counterpart, he lives around here too.
very late. So the question's a good question. It depends on the nature of the data. And the point is you have different compression algorithms that you can use. So take a look at a given cluster, a given data set. You may use an algorithm XYZ. That may be the best performing for what it gains from you on the compression side. However, there may be another data set that you have that you may want to spend more processing time getting a better level of compression, right? Because compression affects what? The data set as well as the replication of data. So the point is you have a lot of different options, and you have that controllability at a lot more granular aspect than you have with the other distributions.
But it's all good. This slide here, we're talking about the aspect of mirroring. So mirroring and data snapshotting, depending on where you are, where you come from, whether you're dealing with a file system or a virtual environment, those names get kind of a little bit confusing because in Hadoop we have the replication factor, which is how many times you copy the exact value of it. There's also mirroring. Mirroring, it doesn't quite mean the same thing as most other people who've been around for a while think mirroring does. Mirroring is taking one copy of the data over here in this data center and making sure that you have the same copies of it over here in this data center. That's the aspects of your disaster recovery, and that's done. Takes about 10 minutes, a couple of minutes to set up, and it's done asynchronously depending on your comfort level. There is no magical short circuit to go from data center 1 to data center 2. There's no Rosenberg-Einstein bridge to move the data instantaneously. You have latency, you've got your pipe, you've got all that kind of thing you have to deal with. So it's a matter of what you have set up to get from A to B, how much data, what's your ingest rate, and then how long you want to wait for copying that over. So you can do it as little as every 30 seconds, begin to move that data, 5 minutes, an hour, once a day. That's all considered depending on what your recovery point is that you want to, what's your potential loss you want to in case your whole data center died, right? Make sense? All right. Multi-tenancy is another aspect that's important. As I said before, having all those different applications in one cluster without having to have an administration nightmare is one of the core aspects that we bring to the table that we like to try to talk about, we like to try to take care of. So a lot of that involves, first off, isolation. So being able to isolate processes, being able to isolate jobs, being able to isolate data sets so that this data that belongs to this particular customer never sits next to the data that belongs to a different customer or a different project. In some instances, it's about controlling data locality to a couple of nodes for SLAs for performance perspective. Because I don't want to spend the time to move it across the wire, if I'm running Impala and 90% of the data that my Impala service runs is, I know what that is. I can configure that to only be on the 5 nodes that runs my Impala service. So it doesn't have to go anywhere to get the data besides where one of those points reside. Data locality is an important aspect for multi-tenancy. Quotas, of course, user quotas, process quotas, application quotas. So being able to limit the amount of data that can be consumed by a user. So a user can only consume so much data of your cluster. A volume that you specify for a customer or a project can only consume so much data. So being able to control how much data comes in and goes out around that aspect of data. But of course, security and security delegation. Now, everything about, and I may not have mentioned this, but the file system is a read-write file system. So you can go in, you can edit it, edit the aspects of it because we're aware of an 8K level. It may be sharded with a 256 megabyte jump, but you can edit at an 8K level. I mean, if you edit a bit, only the parts that change will be replicated and fixed at that point. It's an editable file system. It's also POSIX compliant, so it ties in with the Linux PAM module. So we have easy time with Active Directory, LDAP, Kerberos, all that kind of stuff. When it comes to turning on wireline authentication takes about 10 minutes to set up and get running. You can use the SSL type encryption. You can use the keys that we generate with our methodologies, or you can turn around and run everything in Kerberos. So you have multiple options then to support whichever levels you need to. So,
Can I ask you a question about security?
Mm-hmm.
What is it that makes our systems vulnerable, that you constantly read about some small group in a small town in Russia or China? Or are these intrusions preventable using what you're talking about?
Well, it definitely helps, but really, it's right now it's more of a numbers game. As the rest of the world has started to do a lot towards changing some of the credit card and processing methodologies, we haven't changed in a long time.
We mean in the country, government, or what?
So you've got most of the hackers in the world are all focusing everything they do on getting information from the U.S. right now. because because once you get those numbers, it's easy to spend the money. So that's
We're an easy target?
yeah.
Okay.
Well, we're a prime target. So that I mean, the levels of what turning on encryption, getting off of passwords, making sure you're encrypted across the wire, so that all your access points are controlled, and you have to be encrypted to even begin to get a point established is the first aspect towards keeping that happening. But most of the breaches you're talking about are internal. Somebody walks something in, a contractor puts a bit of Trojan aspect of it in. You've got some other ones that penetrate, remotely, but most of the severe breaches that lasted a long time, where they pulled lots of information, were internal because security methodology inside the company were like, oh well, they work here, they're not, they're not going to do that. As an example, a large company that deals with home repair products is not to be mentioned. I was working with some of the aspects when I was looking at their code base on site. The entire code base of how they run their applications and the finance and different aspects of the registers inside the company, they actually didn't restrict who could read it. So anyone who was sitting in the company, was on the network, could check out the entire code base on what they run all their projects on internally, right? So, but there's all kinds of things like that come into play. So we're getting better, but it's still scary. And before I was doing Hadoop, I was actually did 8 years as security and penetration testing for a company called View Security. It's been a while. I've been out of the game for a while. So, and reporting aspects of lots of statistics on the board, right? So now this is an complete aspect: volume, understanding of where we place data. I talked to you a little bit about being able to control where that data resides. I look at it this way: the general Apache Hadoop, the other distributed Hadoop, have one large volume of data. It's one Hadoop file system, one distributed file system. Some of the architectural differences of Mapr is being able to actually assign a virtual, kind of a Linux virtual volume, if you will, that says, all right, this is, so if you want it, for instance, if you start getting too many file numbers and file counts for a particular aspect of it, I'll spin off another volume for a project, and now I can easily have more file names and more file counts by spinning off another volume to represent, store more data, or more logical constructs of that data. Being able to also take these volumes and restrict them to which nodes they can reside on. This volume can reside on node 1, 2, and 3. This one can reside on 4 and 5, right? So we'll look at some of that when I bring up a live cluster. We'll just take a look at what that looks like. And then to be able to change the replication, the mirroring, the protection methodologies, access and control, all that kind of stuff based on the volume and what's represented in that volume, means that I can control and say this client only can access this volume, and this client can only access this volume. But once again, from an analytics perspective as a business, all of that data is in one cluster, and I can look at all of it for my business as I'm providing these services and get information about how to maximize what I'm doing. Does that make sense?
So why is that important when you said it's the HDFS and the Apache distribution? It has to reside in one file system, and over here you can distribute it across multiple file systems.
Well, it's one file system. It's a logical representation of that data, so I can apply specific. There's a couple things. It goes to multi-tenant kind of environment specifically, right? If you just have one or two projects going on that feeds one business unit, then off you go and you won't ever worry about this. But if you have a lot of different applications feeding different customers or different business use cases that have different levels of security that are required, different SLAs that I have to meet.
Right, but I'm more interested in saying, because I have done the building the service from the ground up, right?
Mm-hmm.
Because this seems to be significant. All you're trying to demonstrate here is how your Mapr fits into the HDFS, how it's superior than HDFS. Right? So I'm trying to say, if you're dealing with the volumes and the file systems, why is that important? Why do I, as an application team, have to care for it? See what I say?
You've got an idea. I mean, I'll give you some. Constraining the data to a certain set of nodes. Right? Instead of distributing across the entire environment, I have a set of nodes that strictly host this volume, this data, provide that data access.
If you get
so
five
you can think about limiting the compute to those nodes as well. Also, the mirroring and the volume replication is done at a volume level. So we don't have to mirror the entire data set. Let's just take certain data sets, mirror them to offsite for disaster recovery. Let's take other data sets, mirror them to another cluster.
Or other data sets mirror to a development team, so the development has a constant access to real-time data, but doesn't actually touch the real-time data, so I don't have to worry about them breaking it.
So does that work into providing different SLAs for different customers?
Yeah, so as an
You
example.
have customers that have
Yeah.
really
Exactly.
high requirement, they're willing to pay for it, you can dedicate
Yep.
resources.
Yep. I mean, for instance, I can just say, you know what, this is my, you're on the free tier for my service I'm giving you. So you fire your job off and it may take 3 hours to execute. This one's not. So when he comes in, and he gets every node in the cluster to be able to do anything off. But this guy only gets the 5 nodes over here, right? So there's that aspect of it. There's also the aspect of, I said before, when you look at how data, you know, if you look at MapReduce and Yarn and how they do certain things to control it, that works great for the components that use those things that are going to use MapReduce. I can control it with scheduling and queues and some things like that. Yarn, right? If it's using Yarn, I can do some resource constraint around that. If it's not, if it's some new project that comes in, it's not using that aspect of it, how do I control it? How do I limit what it's going to do? Some of the things is by limiting the nodes it runs on. But if I limit the nodes it runs on, it's going and pulling data from all over my cluster, then it may impact other things I don't want it to. So once again, with volume, I can say this new fabulous project that just showed up that I'm testing or using, that I can make sure it runs on these 3 nodes and the data that it's using runs on these 3 nodes, and it's not going to go out and mess with anything else.